Hello friends, welcome to your channel Make Physics Easier by Mayur Agarwal. Today we are going to discuss the last exercise of chapter Factorisation of class 9 from the book Concise Mathematics. So without any delay, let's start today's video. Before starting the exercise, I would like to tell you, in this exercise 5E, you have not to learn any new concept. Like in the previous exercises, we have completed grouping together, middle term splitting, identity of a square minus b square, identity of a cube plus b cube and a cube minus b cube. But in this exercise 5E, we have miscellaneous questions related to all those exercises. So let's start. The question number 1 is saying x square plus 1 upon 4x square plus 1 minus 7x minus 7 upon 2x. This is the question which we have to start. So now, when we move forward, we can see that these three terms which are written over here, they are forming the identity of x plus 1 upon 2x whole square. How can we say? Because you can observe very easily x square can be written as x whole square and 1 upon 4x square can be written as 1 upon 2x square. Now in rough work or simply in our mind, we can calculate this. So the answer will be like x square plus 1 upon 2x whole square. 2ab is also there. So we'll write like this. 2 will be cancelled and x will be cancelled. So 1 only will be the remaining. And other terms we already understand very easily. So that is why these three terms can be written as this whole square. Now in the last two terms 7 can be taken as common. So again x plus 1 upon 2x. Now it can be written as x plus 1 upon 2x into x plus 1 upon 2x two times because square is there. Minus 7 x plus 1 upon 2x. So overall we can say that x plus 1 upon 2x is common and the remaining x plus 1 upon 2x from the first term minus 7 from the second term. So in these three steps we can solve this question. But before starting the steps, this is also very important. Because if you will not understand that which identity we are following here, then you cannot proceed into the next step. So the use of all the identities is very important. So this is the first question of exercise 5E. So proceeding further, we are coming to the next question, question number 2. The only quality which we have to develop in this question is to learn all the identities and to apply them immediately. Question number 2 is saying 9a square plus 1 upon 9a square minus 2 minus 12a plus 4 upon 3a. Similarly, like in the question number 1, first of all we have found the identity. So the first three terms, they are forming the identity of 3a minus 1 upon 3a to the whole square. Now you can make it clear from the rough work. You can open it by a square plus b square and minus 2ab. So when you will open this, 3a will be cancelled with 3a. The answer will be 9a square plus 1 upon 9a square minus 2. So that is why these three terms can be written as 3a minus 1 upon 3a to the whole square. In the next two terms, we can take 4 as common. So again, 3a minus 1 upon 3a can be written in the another bracket. So it can be written as 3a minus 1 upon 3a and 3a minus 1 upon 3a twice because whole square is there, minus 4, 3a minus 1 upon 3a. So now we can take 3a minus 1 upon 3a as common. So from the first term the remaining will be 3a minus 1 upon 3a and from the second term the remaining will be 4. So these are the three steps of this question also. So this step you have to understand very clearly, then only you can proceed. So you have to find out the whole square and positive whole square and negative whole square identities. Then only you can proceed. Now coming forward, we are coming to the next question, question number 3. In question number 3, we have some terms like this. It is written x square plus a square plus 1 upon a x and plus 1. So this is the question. So now how can we solve it? So you have to take, you can take LCM. So one is there and one is there. The LCM will be a only. So it will become ax square. It will remain same and it will become a. So 1 upon a you can take separate, and in the brackets take ax square plus a square x plus a. Now, in the first two terms, you can take ax as common. So, in bracket, x plus a will be remaining. And in the last two term, nothing is common. So, you can take 1 as common. So, again, x plus a. So, x plus a in the first bracket and ax plus 1 in the second bracket. So, in this step, as I told you, if any term is given in fraction, then it will be better option for us that we can take LCM, and after taking LCM we take denominator separately, 1 upon a separately and other terms in the brackets, and in the other terms we apply middle term splitting method or any other method which is applicable in that question, then we get the final answer. This is question number 3. Now we are coming to question number 4. X to the power 4 plus y to the power 4 minus 27 x square y square. Again, we have three terms. So first of all, in our mind, middle term splitting can become. But in this question, middle term splitting cannot be applied. In this question, first of all, we can see that this can be written as x square to the whole square, and y to the power 4 can be written as y square to the whole square. Now, if we want to make the identity a square plus b square minus 2ab, then there must be minus 2x square y square. So, the 27 can be written as 25x square y square. So, we can see that we have just broken down minus 27 into minus 2 minus 25. Some of the students were thinking that how cannot we make 29 minus 2, that results also 27, but 29 is not a perfect square. 25 is a perfect square, so it is better option. So these three terms can make the identity of x square minus y square to the whole square, and this can be written as 5xy to the whole square. Now a square minus b square. In the first bracket a plus b, and in the second bracket a minus b. So this is the final answer of this question. If more steps are possible, then we proceed. Otherwise, we have to leave the answer only at this step. So as we can see that in first of the step, we have to break 27x square y square. Why are we breaking? As I told you, because the first two terms are perfect squares, and the variables added to 27 also related to the previous terms. It means if we break this term into any such two parts, when the first part will be 2, then it can make the combined identity. So we have two options, either we can write 29 minus 2 or we can write 25 plus 2. So why are we taking 25 plus 2? Because 25 is also a complete square. So according to the next question, we are proceeding forward. That is written 4x to the power 4, 9y to the power 4 plus 11x square y square. Now in this question, as you can see, this can be written as 2x square to the whole square, and this can be written as 3y square to the whole square. When in the rough work or in mind, you will apply 2ab. So you will write like this. So 2 to the 4th is a 12x square y square. So you need 12x square y square with them to make an identity. So you have to just break this into like 12x square y square minus x square y square. There are so many methods to break 11, but we have to break in such two parts that one of the part has come 12. Now these three terms can form the identity of 2x square plus 3y square up to the whole square minus x square y square can be written as xy whole square. So this will be acting as A, this will be acting as B. In the first bracket, A plus B, and in the second bracket, A minus B. So this is the term. How can we solve this question also? So now we have to proceed forward, and we are coming to the question number 6 now. So as I told you, in each of the question there will be a small difference, but the basic need is understanding all the identities very well, and to apply them at immediate point, at a certain point, then only you can proceed. Because in this exercise all of the questions are miscellaneous, so it is difficult to find out that which method will be applied, because in the previous exercises the exercises are classified according to their type of question, and in exam also the exercise type questions will not be there. So you have to imagine that which type of question it is, and then you have to solve that. Now we are coming to question number 6. Question number 6 is saying x square plus 1 upon x square minus 3. That is also a very easy question. We want 2. So minus 2 minus 1. The first three terms can be written as x minus 1 upon x whole square, and 1 can be written as 1 whole square. A square minus b square. So in first bracket a plus b, and in second bracket a minus b. So this is the final answer of question number 6. Now question number 7 is saying a minus b minus 4a square plus 4b square. In the first two terms you have grouped together. In last two terms 4 is common, so a square minus b square. You can apply the identity in a square minus b square. So a minus b and a plus b. Now there are two terms. In both the terms a minus b can be taken as common. So from the first term 1 will be remaining, minus 4 a plus b will be remaining. So just open it. A minus b, 1 minus 4a minus 4b. So that is the final answer. So in this question we can see very easy, because all the steps are clearly shown in the question. Question number 8 is saying, that is a little large question, so I am writing here 2a minus 3 up to the whole square minus 2a minus 3 into a minus 1 and plus a minus 1 to the whole square. So now you can see 2a minus 3, 2a minus 3, a minus 1, a minus 1. So let 2a minus 3 is equal to x and a minus 1 is equal to y. The question will become x square minus 2xy plus y square. So this can be written as x minus y to the whole square, and x minus y, apply the values. So 2a minus 3 minus a plus 1 to the whole square. So 2a minus a will become a, and minus 3 plus 1 will become minus 2 whole square. So a minus 2 and a minus 2. So this will be the final answer. So when the terms are like this written in the question, that they are repeating, these two terms are repeating at the other places also. So that is why first we have considered them. Now after considering them, we have very short term, and it is clear that this is the identity of x minus y whole square. So we have just placed the values of x and y, then we have simplified, we got this answer. So this is question number 8. Now we are proceeding further to the question number 9. So as I told you, and I am repeating my point again and again, if you want factorization and expansion, both the chapters completed, and any question related to these two chapters you want to solve in your examination confidently, then you have to learn all the identities and try to practice, because these chapters has no limit. So many types of questions can be made. So your practice will make you perfect. Now we are coming to question number 9. In question number 9, it is saying that a square minus 3a in first bracket, 4a square minus 4a minus 5, a square minus a is written here, and minus 6. So first of all, we are observing that in this bracket 4 can be taken as common. So a square minus a, minus 5 minus 6. Now we have considered a square minus a is equal to x. So the question will become x, 4x minus 5 and minus 6. Now multiply it. 4x square minus 5x minus 6. 4 6 are 24. So 8 and 3 will be the numbers. 4x square minus 8x plus 3x minus 6. In first two numbers 4x is common, so x minus 2. last two numbers 3 common, so x minus 2. X minus 2 in the first bracket, 4x plus 3 in the second bracket. But this is not the final answer. We have considered x as a square minus a. So a square minus a minus 2 and 4a square minus 4a plus 3. Now we have checked that can these bracket be solved. So let's try to solve it. A square minus 2a plus a minus 2, 4 3s are 12. So this cannot be solved, I think so. 4a square minus 4a plus 3. This will remain same. In this bracket, a can be taken as common. So when you have taken a as common, so a minus 1 and from here a minus 2. So I hope so this can also be not solved with the help of this. The numbers product must be 2, so we have taken 2 and 1. Yes, here a minus 2 will be remaining and 1 common, so a minus 2. Yes, this bracket can be solved. Second bracket we cannot solve. Second bracket will remain same. So from the first bracket, two brackets will become a minus 2 and a plus 1. And from the second bracket, the terms will remain same. 4a square minus 4a and plus 3. So that is the answer. Sometimes the third bracket can also be solved, but if it is not solving, then we have to leave that, because 4 3 are 12. There are not possibility of any two numbers. Their multiplication is 12 and their addition is 4. So no number is possible. Now we are coming to the next question. Question number 10. Question number 10 is also like this. Okay, I have solved right now question number 10 in front of you. Now I am telling you question number 9 because they are similar. So I have copied question number 9 in the place of this. Now question number 9 is saying a square minus 3a, a square minus 3a plus 7 and plus 10. This is the question. So in this question we can easily say that what is the common? A square minus 3a is equal to x. So x plus 7 plus 10. So x square plus 7x plus 10. Break it with the help of middle term splitting. 5x plus 2x plus 10. In the first two numbers, x taken be as common. So x plus 5. Then 2 taken as be common. X plus 5. So x plus 5 in first bracket. X plus 2 in the second bracket. Now apply the value. A square minus 3a plus 5. And a square minus 3a plus 2. This bracket cannot be solved, a square minus 3a plus 5, but this can be solved. So a square minus 2a minus a plus 2. First bracket will remain same. In second bracket, first two terms a can be taken as common, so a minus 2, 1 taken common, a minus 2. So first bracket will remain same. And according to the second bracket, a minus 2 in the first bracket, a minus 1 in the second bracket. So similar question as like 9 and 10 are very similar to each other. So it is not compulsory that always all the brackets where a quadratic equation has formed, a quadratic expression has formed, it can be factorized. It is not compulsory. If it is possible, then we have to factorize it. Otherwise, we have to leave that answer. So this is question number 10. Now moving forward, we are coming to the next question, question number 11. I have explained you all because you have to practice with yourself. If you are finding any problem in any question, then you can check with the help of these videos. It is not like that you are going through just videos and then solve the question. First, try to solve with yourself. If you have any problem and I am not available, then you can take the help of these videos. Question number 11 is saying x to the power 4 plus y to the power 4 minus 3x square y square. This is also very simple. You have to break. So when you will break, it will become 2x square y square minus x square y square. So first three terms, they will be forming the identity of x square minus y square to the whole square. And it can be written as xy to the whole square. This is acting as a, this is acting as b. So a and plus b, and in the second bracket a and minus b. So this will be the final answer. Such type of questions we have already solved. Now question number 12. It is saying that 5a square minus b square minus 4ab plus 7a minus 7b. So first of all, we will solve these terms. It can be written as 5a square minus 4ab minus b square. and 7 is common, a minus b. It can be solved with the help of middle term splitting. So when you will split the middle term, it can be written as minus 5ab plus ab minus b square plus 7a minus b as it is. In the first two brackets, 5a is common, so a minus b. In the next two brackets, b is common, so a minus b again. 7a minus b. So in the brackets, a minus b in first bracket, 5a plus b in the other bracket, 7a minus b. Now a minus b can be taken as common. When you take a minus b as common, so from the first term 5a plus b will be remaining, and from the second term plus 7. So this is the final answer. So in this question, it is very difficult to find out the grouping of these three terms. Why we are grouping these three terms? Because a square, b square and ab is also there. So in our mind, first thing is coming that any identity can be applied here. But for the application of identity, there must be 10ab. Because 5a square root 5a whole square, so there must be 2 root 5ab. Then we can apply the identity. But this is it not complete square, neither 5 nor 4. So that is why we have found that to solve with the help of middle term splitting. And for the middle term splitting, a square and b square can be in corners and ab term must be in middle. So that is why we have made it like this, and then we have taken common. Now we are coming to the next question, question number 13. Question number 13 is saying 12 3x minus 2y up to the whole square minus 3x plus 2y and minus 1. So first of all, the first term can be written as it is. Now you can take minus as common, so 3x minus 2y it will become minus 1. Now you have to consider 3x minus 2y is equal to a. The question will become 12a square minus a minus 1. Now just break it, 12a square minus 4a plus 3a minus 1. From the first two terms, 3a is common. So 4a is common in the first two terms. So the remaining will be 3a minus 1. Nothing is common, so 3a minus 1. So in first bracket, 3a minus 1. In second bracket, 4a plus 1. Now consider, place the values. So 3x minus 2y minus 1. Now 4, 3x minus 2y and plus 1. Now just simplify it. 3 3s are 9x. 3 to the 6y minus 1, 4 3 the 12x, 4 to the 8y and plus 1. So this is the method to solve question number 13. In this also we have no problem to solve because such questions we have already solved. We can see that here 3x plus 2y is written. So first of all we have to make negative sign as common. So 3x minus 2y it will become. Now 3x minus 2y lies here also and here also. That is why we have considered it a. So this is the question number 13. Now proceeding further, we are coming to the next question, question number 14. Let's see what method it will take. In this also we have to consider. So question number 14 is saying 4 2x minus 3y up to the whole square minus 8x plus 12y minus 3. So first term will remain same, nothing changes. In the next two terms we can take 4 as common. So again 2x minus 3y. Now we can consider 2x minus 3y as a. So the question will become 4a square minus 4a minus 3. 4 3 is 12. So 6 and 2 we can break. 4a square minus 6a plus 2a minus 3. In the first two terms 2a can be taken as common. So 2a minus 3. Nothing is common. So again 2a minus 3. 2a minus 3 in first bracket. 2a plus 1 in the second bracket. Now apply the values of a. So it will become 2x minus 3y. Minus 3 in again a value 2x minus 3y now plus. Now solve it. It will become 4x minus 6y and minus 3. It will become 4x minus 6y and plus 1. So this is the final answer of question number 14. So as we can see that in all of the questions, first we have to make the terms similar, then we have to consider any of the term that is which is common, which is similar. Then according to the new question we have to solve, and after completely factorizing we have to place again the value of that considered part. Then we find the final answer. So this is the question number 14. Now proceeding further, we are coming to the next question, question number 15. Question number 15 is saying, again it is similar question, 3 minus 5x plus 5y minus 12x minus y whole square. In the first term 3, as it is minus common, 5 common, x minus y minus 12x minus y to the whole square. Now we have considered x minus y as a. So the question will become 3 minus 5a minus 12a square. So 3 minus 9a plus 4a minus 12a square. In the first two numbers 3 can be taken as common. So 1 minus 3a. In the last two numbers 4a can be taken as common. So again 1 minus 3a. 1 minus 3a in first bracket, 3 plus 4a in the first bracket. Why are we writing 9 and 4? Because 3, 12. When you will find the product of 12 and 3, the result will be 36 and the coefficient of a is 5. So we have to find out two numbers. Their multiplication should be 36 and their subtraction should be 5. That is why we have broken it into parts 9 and 4. Because 9 4s are 36 and 9 minus 4 is 5. Now apply the value of a. 1 minus 3 x minus y, and after that 3 plus 4 x minus y. Now just open it. So it will become 1 minus 3x plus 3y, and it will become 3 plus 4x minus 4y. So this is the answer of question number 15. In this also we have considered that the first part we have to think about, and after that middle term is splitting and then placing the values of a. Now we are coming to the question number 16. Question number 16 is saying 9x square plus 3x minus 8y minus 64y square. So this is the question. So we have to make these two terms group together. 9x square minus 64y square together and 3x minus 8y together. Now when you will apply the whole square, 3x whole square minus 8y to the whole square, and this term will remain same. Now you will apply a square minus b square. So a plus b in the first bracket and a minus b in the second bracket, and 3x minus 8y will remain same. Now you can take 3x minus 8y as common. So from the first bracket 3x plus 8y will be left, and from the second bracket 1 will be left. So this is the solution of question number 16. So sometimes you have to, like, why are we grouping these terms together? Because this is also perfect square, this is also perfect square, and sign between them is negative. That is why we can apply the identity of a square minus b square. That is why we have grouped together. So from this question it is clear that you have to jump on one step forward, then only you can solve, because you have to be very logical while solving the factorization questions. Now question number 17. 2 root 3 x square plus x minus 5 root 3. I have observed that many of the students will be cannot be solved root questions because they consider that root questions can be solved with the other method. And I am telling you there is no other method to solve such questions. Again, the coefficient of x square is 2 root 3. The constant is 5 root 3. So first of all multiply them. 10 into 3, the answer is 30. And the coefficient of x is 1. So we have to find two numbers. Their multiplication is 30 and their subtraction is 1. So 6 and 5. So 2 root 3x square plus 6x minus 5x minus 5 root 3. In the first two numbers you can take 2 root 3x as common. So x will be remaining plus. Now when you will divide this, so easily you can say 3 by root 3 is coming. Now 3 can be written as root 3 into root 3. So 1 root 3 is also cancelled. Only root 3 is left. And plus root 3. In these two terms you can take minus 5 as common. So again x plus root 3. So x plus root 3 in first bracket. 2 root 3x minus 5 in the second bracket. So there is nothing different in this question. We have to follow all the procedures similarly. But the only thing is, while we are taking common, then we have to be very careful. Because these are not numbers, so they cannot be taken or solved directly. So we can just solve them in rough work or in our mind. Then we have to leave the answer. So this is question number 17. Now proceeding forward, we are coming to the next question, question number 18. In question number 18, it is also looking little different. 1 upon 4 a plus b to the whole square minus 9 by 16 2a minus b to the whole square. Now there are only two terms and both are complete squares. This can be written as 1 by 2 a plus b to the whole square, and this can be written as 3 by 4 2a minus b to the whole square. If in your mind that point is coming that you should multiply them, then you are wrong. Why? Because our target is not to expand the terms. Our target is to factorize, make more brackets. That is why it will not be convenient to multiply them. Now a square minus b square. In first bracket a plus b, and in second bracket a minus b. Now you have to simplify also. So when you are going to simplify, it will become a by 2 plus b by 2 plus 6a by 4 minus 3b by 4. In second bracket a by 2 plus b by 2 minus 6a by 4 plus 3b by 4. Now this can be written as 3 by 2. So 3a by 2 and a by 2. It will become 4a by 2 and positive b by 2, and it can be written as LCM 4. So 2b minus 3b. In this way, b term together we are solving and a term together we are solving. Similarly, in this 3a upon 2. So it will become minus 2a upon 2 and plus it will become, because both are positive, so 2b plus 3b upon 4. Now it will become 2a plus, it will become minus b upon 4. And in the next bracket it is minus a plus 5b upon 4. So it will become 2a minus b upon 4 and it will become 5b upon 4 minus a. So that is the final answer. Or if you don't want to written 4 in the bracket, then you can take LCM and make 4 outside. So in the first bracket it will become 8a minus b upon 4. And in the second bracket you can write 5b minus 4a upon 4. So this 4 and this 4, it will become 1 by 16. 8a minus b and 5b minus 4a. So that will be the final answer. So this is also the easy question, but little lengthier because steps are very high. Now we are coming to the next question, question number 19. So in question number 19, again we have to first find the first term, that which we have to follow. Yes, it is a little difficult question. You have to consider it first also. 2ab plus cd. After that minus a square minus b square plus c square plus d square. First of all multiply. So 2ab plus 2cd minus a square minus b square plus c square plus d square. Now you can make one thing. C square plus d square plus 2cd. These group together minus a square plus b square minus 2ab group together. So they will be form the identity of c plus d whole square. And they will form the identity of a minus b whole square. Now a square minus b square identity. In the first bracket a plus b, in the second bracket a minus b. So that will be the final answer. So along with the grouping, we have to be very careful while the calculation, while the changing of sign, because these two are negative and 2ab is positive. So I have taken minus as common. That is why these two terms will become positive and this will become negative. And why I am doing so? Because in identity, either it is of a minus b whole square or it is of a plus b whole square. A square and b square must be positive. Then only we can apply the identity. So this is the question number 19. Now we are coming to the last question. In this we have to find the values with the help of applying the identities. So I am telling you the fourth part. Remaining part you can solve with yourself very easily. 18.5 whole square minus 6.5 whole square divided by 18.5 plus 6.5. So in the numerator, a square minus b square identity can be applied. So in first bracket a plus b, in second bracket a minus b, and in denominator 18.5 plus 6.5 is there. This can be cancelled. So final answer is 18.5 minus 6.5. The result will be 12. So this is the question number 20th, fourth part. So all the questions of question number 20 are like this only. You have to apply the identity of a square minus b square. So this is the solution of questions related to exercise 5e. Now you have all the solutions of factorization chapter from Concise Mathematics. But those students who have not this book, ML Agarwal book or any other book, they can also take the help of these videos, because mostly questions are same. Some questions are different, their numbering is maybe different, but question will be same and the concept will be same. So I hope so you will watch my video. If you have not subscribed yet, subscribe and like it and share it. Thank you.